All right, guys, welcome back. Unfortunately, we're not in person, and I decided that my internet just is not good enough to support me sharing my screen and talking to all of you without it blipping out all the time. So, unfortunately, I have to wait till Wednesday to see you in person. But I hope this video will make it a little bit easier than if we were doing a Zoom call. So. First off, I just wanted to point out a few things. I picked period 7 to do the Google Classroom with, but it's the same with period 6. So one thing that's going to be a little bit different this quarter is everything will be from the stream right here in the planning calendar. If you click on this, then this comes up. I should have just went right here. This comes up, and this is the calendar, and I have it updated for this week. This week is completely done. So today is my A group, which would be in person right now, and then the B group will be doing the remote lesson here. So this is all the same as what you've seen before, except the one thing is all the presentations will be in in the lesson right here. They will not be in the classwork section of Classroom. So the only place to find the presentations is right here in the lesson. And then the only thing that's in the classwork session of Google Classroom will be the assignments, okay? So if you click right here on the presentation, which is for the 15th, then it will take you right here, okay? And so this is what we will be going over today, and I'm going to walk you through the main parts of this, and then there is a very easy to do activity that doesn't need me. So here we go. So we're going to start with projectile motion. There is a 10-minute, 45-second video that I want you to watch and take notes on, and I have a note sheet for you for that, which is an assignment in Google Classroom. We'll have to wait for the demos until we are in person for the ball popper and the table drop, but you will see the PhET simulation in a moment. This catapult video, we're going to be doing video analysis this quarter, and so I'm going to show you how to do that video analysis here. And then the PhET projectile motion is an activity that will be due Friday, and it's a great way to review projectile motion. So, and then we'll have a semester 1 review quiz. I believe it will be Wednesday of next week, but it may be Thursday, depending. We'll see. And then coming to this slide is just all the slideshows will be here. This is a link to the website. This is a link to Google Classroom, and this is a link to that planner that I just showed you. Here's what's due. The projectile motion video notes are due by 2 p.m. Friday. You really should get these done right now today. It's 10 minutes and 54 seconds of the video and just filling in what he goes over. And then the PhET projectile motion is also due Friday at 2 p.m. This one's a little bit more involved, but you should get a good start on it today and just play around with it to see how it works. This is... So if you're in period 6 or period 7, you just click on this. It'll take you to the Google Classroom link. This is the video that you will watch, and then fill in the missing information. I believe that it is, I thought I had that up, sorry, forget it. Anyway, it'll take you to the Google Classroom where that's located. These are the formulas for projectile motion, and if you come back over here, that is right there. It says projectile motion formula sheet, so it's right here for you, and you can click on that link and have that, but I'm going to come to it right here. So I highlighted the formulas that we'll use due to time constraints this quarter. We're only going to look at horizontal projectile motion, and so I've highlighted the formulas that you'll use. So you'll have your velocity in the x direction is equal to your distance in the x direction divided by time. Your distance in the x direction is equal to the velocity in the x direction times time. And then this is a really important formula over here, that the time that a projectile is in the air is equal to the square root of 2 times its height divided by gravity. Okay. Sometimes we'll call height distance in the y direction, so just be careful about that. That this h right here could be d sub y or just height. So that formula will be used often. The distance in the y direction is equal to the initial velocity in the y direction times time. I have this in purple because this is usually 0, and so we can neglect this part of the formula and just focus on the 1/2 gt squared. Okay, so when we did free fall, that was this right over here. And then we have velocity in the y direction final is equal to velocity in the y direction initial. Again, this is usually 0, so I have it purpled. And then plus gravity times time. Okay, and those are the only formulas that you'll really use. This one over here, we possibly will use this one, that if I knew an object we're traveling up at 20 meters per second, then I would know it would be in the air for a total of 4 seconds, because it will go up for 2 seconds and down for 2 seconds, but I'll cover this one in class a little bit more later, okay? So those are your formulas right there. And then this is a lab that we'll be doing remotely. It's a projectile motion using that Vernier video analysis, which I'll show you in a moment, where you'll be looking at a ball that's rolling off a table, and based on the speed it rolls off the table and the height of the table, you'll determine where it lands. And so I'll go over that with you in class before I make that assignment for you. And then here is a catapult video and the video analysis link right here. This video analysis link, by the way, it should be, if I come to classwork over here, under resources, here is the Vernier video analysis link that you guys can download. There's also under resources a link for tutoring if anyone needs that. And then again, here are all the assignments, and only the assignments are under classwork. So today for in-person, you have the projectile motion video notes. Here's the video notes you'll fill in, and here's the video right there. And then here is the PhET projectile motion worksheet. This is the simulation that you'll use, and then this is what you'll fill in, and I'll go over that with you. And then, so let me come back over here. So when you click on video analysis, it will take you to here. And then I am going to just show you that if you're using your own video, there's going to be a time later when I'm going to have you import your own video. I have a video that I'm going to import. It was that catapult one. So I click on import video. And then I have mine right here, catapult, under movies. A lot of times it'll be under downloads. And if I open it, it will bring it in for me, and it's right here. Okay, so I'm just going to show you a few things about this. I can move this tab over to make this a little bit bigger. I had Mr. G help me out with this, and so I'm going to play the video. So this is right here, and just show you what the projectile looks like when it goes through the air. So in slow motion, you can see it follows a nice parabolic arc. Okay. And then, so I'm going to pause that and bring that back all the way over until it's right in there. And again, I'm going to play it one more time, and then I'm going to pause it. And then I can use these over here to go backward frame by frame or forward frame by frame. And I'm going to go back as I click back, and you're going to see it's going to go right back. And right there is where it is leaving the catapult. So then I'm going to come over here, and I am going to click on system, and the system here is going to allow me to use this, and there's a meter stick right there in the window. I don't know if you can see that, but I'm going to set that to there. Okay, so now I've got my 1 meter measured right here, so it tells me how many pixels equal a meter. I'm going to set my origin, and so I'm going to set my origin right where the ball is leaving the catapult, right there. And then there's one other thing. I did this in slow motion, so if I come down over here to where this little gearbox is and go to advanced video options, it's going to allow me to change my frame rate. And so my frame rate for this one, I believe was Uh, no, I can't remember. I think it was 200 frames per second, and I might be off on that, and that's okay. And then so I'm gonna just click off of here, and now it's switched to 200 frames per second. I think that number might be off, but that's all right for what I'm going to show you now. So now I've got my origin set. I've got my frame rate set, which is going to use to calculate the time. And then I've got my meter stick that I did in here. And so now I'm going to add points. So I come up right over here and I click on add points. And I'm going to click, and it's really hard to see, so I'm going to zoom in a little bit on the ping pong ball that's being catapulted. And it went, you can see it moved a little bit. So I'm going to use this right here to advance it a few more frames. And then I'm going to click on it again. And I'm going to just kind of do it a few frames at a time. It'll keep track of how many times I'm advancing it. And you can see it's still going up. And you can see it's nearing the top of where it's going to go to. It's going to go ahead of the clock right there. It's just about at its highest point. Let's see if it goes any higher. It looks like it's a little bit higher there. But now it's going to begin to start coming down. And it looks like that started now. But anyway, you can start to see that it's starting to form a nice little parabola as it goes over here. And then so a few things to notice, that it was going up, 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 but then it slows down in its upward trend, and then it begins to come back down. So one thing that you'll see is the only force that is acting on a projectile once it is left the catapult, the only thing acting on it is going to be the force of gravity, the weight of the ping pong ball in this case, or the golf ball that I had Mr. G launch. Okay, so I'm going to show you more with this, how we're going to analyze its velocity and things like that as we go through. But I just wanted to do a quick one with you right now, just so you could see how it goes. And then so I'm going to move on from that and then come to here, which is the last thing. And this is that PhET projectile motion assignment that you're going to have. And again, if you click on here, it will take you to the link that will bring you here. All of these are valuable, except lab is where you're going to do most of your work. So I'm going to click on that, and you can see that you can adjust the height of the cannon, you can adjust the angle of the cannon, you can adjust the speed that the cannonball will come out of the cannon, you can move the target, which you will be doing, you can adjust the mass of the cannonball, you can adjust the diameter of the cannonball, you can change what gravity is, you can make it so there is air resistance or so there's not air resistance, you can change the altitude. There's a whole number of things that you can do as you go through. You can take out a meter stick and you can measure different things. But this tool here is actually more important, and I'm going to kind of show you something here right now. So if I set this at 0 degrees, and I'm going to bring it down to just, all right, we'll do 7 meters. And I'm going to launch it fairly slow. I'll just leave everything the way it is, and I'm going to shoot the cannonball, okay? And then I'm going to shoot it faster. And I'm going to shoot it faster. And you can see that the 3 different times I shot it, it went further each time as I increased how quickly I shot it out of there. But I want you to think about this. Which one stayed in the air longer, do you think? And so think about that for a second. So when they were launched, they were all launched horizontally, and I increased the speed. And so this one clearly went way further. And so I want you to think about, how long do you think it was in the air? How much longer than this one was in the air? Or is it in the air less time, more time? What do you think? And so I'm going to come over here and I'm just going to show you that if I highlight over here, this cannonball was in the air for 1.1 seconds and went 9.9 meters. And the height above the ground is 0.04. It's basically on the ground. If I come over here, what's it going to read for the time? This time again was 1.1 seconds. This time here, it's going to be 1.1 seconds. Okay. And if I come over here, it's off the screen, but I guarantee you it's 1.1 seconds. And it is 1.1 seconds. The only thing that determines how long a projectile will be in the air is how high it starts from. Okay. The only force that is acting on it is the force of gravity. Doesn't matter how fast it's going horizontally, it's going to fall. If you shoot a gun horizontally and you drop a bullet at the same time, they hit the ground at the same time. Okay, we'll talk more about that later. Use this to answer the questions on that sheet, and I hope you have a wonderful rest of your day. Look forward to seeing you guys next class.